Okay, so number 5 is a context-based word problem for one of our sequences. Let's see what's happening here. The health office is tracking the number of cases of sinus infections at El Camino. There were 5 cases in the first week of the semester, and the number of cases doubled each week. So what type of sequence fits this situation? We're choosing between arithmetic and geometric. Since the number of cases is doubling, we know that this is a geometric. So we're going to say that the situation is geometric because the number of cases is doubling each week. Okay, how many cases are reported in the 10th week? Write a recursive and explicit. Here we go. So writing the recursive, in the first week, there were 5 cases. So we're going to start by saying f of 1 equals 5. Then it doubled each week, means f of n equals f of n minus 1 times 2. How'd you do? For the explicit, we began with 5 cases, doubling each week, each time to the previous term. So this is an exponent of little tiny n minus 1. Go look and see if you got that, because it's repeatedly multiplying. How many cases are in the 10th week? So now we're going to actually go do an input of 10. So 10 for the 10th week is what I'm plugging in because it asked us right here for the 10th week. So now you need to go and put that into a Desmos calculator or something. So 5 times 2 to the 9th. Where did the 9th come from? The 10 minus 1 power. So I'm going to go over here. 5 times 2 to the power of 9. So where did this little power come from? Do you see this A to the B button? That's how you get the exponent in there. So 2,560 cases is our 10th term. So we would say there were 2,560 cases by the 10th week. Okay. Finally, sketch a graph of the situation. So if you feel more comfortable making a quick table, I'm going to go off to the side here just to get a couple data points. So in the first week, there were 5 cases, and then it's doubling. So 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40, 40 times 2 is 80. So if over on the side, we go like this, 10, 20, 30, 40, 50, 60, 70, 80. And then over here, just 1, 2, 3, 4, 5. Now, what does this represent? Down here represents the number of weeks. And on the side represents the number of cases. Remember that every graph needs to be labeled and scaled. So let's go put a couple dots on there. 1, 5. It's only going to go up halfway to right here. 2, 10. Hang on, that one doesn't look like it's halfway. It looks too far up. 3, 20. 4, 40. And 5, 80. I don't know, something like that. Remember, we're just sketching. Now, because this is a sequence and it doubled each week, we don't know what's happening in between that, so we are not going to connect it. Remember that sequences are discrete, not connected. So that was an example of a geometric where we were doubling each week. Let's see what the final one says here. Counseling office is tracking the number of students failing at El Camino. There were 560 students failing at least one class on the first day back. there are 20 fewer students failing at least one class every day thereafter. So because it says 20 fewer students, 20 less than the previous day, that means that we're talking about a minus 20. So this one's going to be an arithmetic sequence because the number of students failing goes down by 20 each day. Writing the recursive. On the first day back from break, there were 560 failing. And then every day thereafter, there were 20 less, 20 fewer. So it's a minus 20. The explicit goes like this. We began with 560 and then 20 more, 20 fewer students failing at least one class every day thereafter. And then this is a big n minus 1 because we're repeatedly subtracting instead of multiplying like the last one. Now with this explicit, they're asking us to plug in, if you look up here on part D, on the 18th day back from break, how many kids were failing. So I'm going to go plug in f of 18. And this is for part D. I'm just doing the work down here. So 18 minus 1 is 17. 20 times 17 is 340. And then 560 minus 340 I'm getting 220 students. Yeah. Okay, so we then write our sentence for part D. We'd say after 18 days after break, there would be 220 students failing. This is part D. Okay, sketch the graph. So we're starting at 560 and we need to move down to 220 or somewhere down there. Again, this is going to be down here at 0 somewhere. And so we're talking about a quick table maybe to reference. And so on the first day, there were 560 failing. And it's going down by 20 each time. So 540, 520, 500, 480. And we're going to see a downward trend on this one because we're subtracting 20 each time. So if each of these was 20, hold on, 20, 40, 60, 81, 20, 40, 60, 82, we don't have enough to get up to 500. So sometimes we use something called a broken axis, where the first couple of dots, we're going to count, let's say we count this up to 200. And then from there, actually, let's call it 300 or 400. Let's go 400. So what we're saying with this broken axis is from 0 to this line, that's jumping 400. And then from there, we're going to go up in 20s, 420, 440, 460, 480, 500, still, sorry guys. Sorry guys. Let's do 500 or 480. We're still not going to have enough. So 480, then 500, 520, 540, 560. So if we go by 20s from there, then I think that's good. So now let's go put a dot at 1, 560. 2, 540. 3, 520. 4, 500. And 5, 480. You can see that linear decreasing pattern there. And then let's label and scale. Don't forget the scale. On the bottom is number of days since break. And on the side is the number of students failing. Okay. So this one is an arithmetic sequence because the number of students failing goes down by 20 each day. Notice our graph is days and number of students. How'd you do on that one?